sir, it is on.
Hello students, am I audible sir? Can you please confirm everyone, am I audible? In the chat box, students please respond, am I audible or not sir? Students, am I audible? Can you please respond in the WhatsApp group, sorry chat box? Very good Swetanshu. Okay, welcome to IMS Gate Academy my dear students. There was a technical glitch, sorry for that. So once again I will start the session. Welcome to IMS Gate Academy. Myself Sandeep Adari here to explain you the concepts of Geotech. My dear students, as we are inching towards the GATE exam, you might want to brush up all your concepts. Then what are you waiting for? In this most expected question concept or GATE score booster, my intention is to cover all the topics in such a way that we can solve the problems. Okay. So here let us go into the session. So first I would like to tell you about the Telegram group session, my dear students. In the Telegram group, if you want to access the classroom notes of the today's session, it's my sincere advice to everyone, you have to join this Telegram group. Unless you have joined in this session, you cannot be able to access the classroom notes what we are discussing today. Now, my dear students, I proudly say that IMS Gate Academy offers online gate coaching as well as offline gate coaching. Here, what we provide is 800 plus hours of gate coaching. So students, wherever you go, practice makes man perfect. So for that kind of stuff, we are coming with the exercise book, question booklet and previous year 30 years question booklet. In addition to this, why IMS has been success in the past 40 years is we have an excellent program called My Plan session or one-to-one mentorship session. In this, students can directly interact with the faculty, individual faculty and clear their doubts, and they can have their roadway and the preparation strategy for the next year GATE preparation. In addition to this, 130 plus online test series session. Now my dear students, if you are really interested in the preparing for GATE 24, then you have to write the All India mock test series. So at IMS Gate Academy, we offer the online test series also. Now today students, I am here to explain you the concepts of geotechnical. I am here to explain the concepts of geotechnical. So let me tell you two things, my dear students. Now let me tell you two things. Okay. Here in geotechnical, my dear students, I have classified geotechnical into soil mechanics. I have classified the geotechnical into soil mechanics and foundation engineering. So in this today's session, I will cover soil mechanics concepts, students. So geotechnical has basically two parts. One is the soil mechanics part and other one is the foundation engineering, my dear students. So let me tell you where your intention should be focused. When I talk about soil mechanics, in the past 10 to 15 years, we are seeing a question from the properties of soil, student. Remember these chapter names? In soil mechanics, the first chapter where you can expect 99 probability of getting a question is from properties of soil. And the second one I would like to tell you is the consolidation. I am going on the priority basis. Second important topic is consolidation. Third important topic is effective stress with a combination of seepage and seepage analysis. So these are the three and the important concepts. It doesn't mean that you should not read other concepts. These three concepts needs extra attention, my dear students. So whenever I am solving the gate questions also, when I am solving the concepts on related to these three topics, you should be very careful. Now quickly we'll go into the concepts, my dear students. Now let me tell you here, I'm going to discuss about the concept of properties of soil. So students, I'll be directly solving the problems, but I'll give you some insight of the topics, okay? I'll give you some insight of the topics. 1 second, students. Now see students, when I talk about the properties of soil, first you should be aware of the formulas. Formulas are very, very important, my dear students. So let me tell you, when I talk about the formula here, the first formula is the void ratio, which you define as volume of voids upon volume of solids. The first formula we have is the void ratio, volume of voids upon volume of solids. The second formula we have is the porosity, which is volume of voids upon total volume. Students, are you following? So porosity is defined as the ratio of volume of voids to the total volume. Now the relation between void ratio and porosity is the relation between, 1 second student. The relation between void ratio and porosity is N is equal to E upon 1 plus E. Students, before solving the problems, I just want to give you an introduction. What are the relations and what are the important formulas in that chapter? So the relation between porosity and void ratio is N is equal to E upon 1 plus E. And my dear students, we have air content is equal to volume of air upon volume of voids. And remember, my dear students, how much volume of air is present in voids is nothing but air content. And degree of saturation is given by the formula volume of water upon volume of voids. And remember, my dear students, air content plus degree of saturation is equal to 1. So my dear students, these are the important formulas. One is void ratio is defined as volume of voids by volume of solids. Porosity is defined as volume of voids by total volume. Air content is defined as volume of air upon volume of voids. Degree of saturation is defined as volume of water by volume of voids. And relation between porosity and void ratio is N is equal to E upon 1 plus E. And my dear students, air content plus degree of saturation can be written as 1. If you want to convert into percentile, just multiply with 100. In addition to this, my dear students, we have percentage of air voids. Na is equal to N into AC. What is N here? Porosity. And what is AC? Air content. And Na is the percentage of air voids. So these are the basic formulas for the properties of soil topic. Now, my dear students, here we have another important formulas. E is equal to water content into G upon SR. Very, very important formulas. What is water content? Water content is nothing but weight of water upon weight of solids. What is water content, my dear students? It is nothing but the ratio of weight of water to the weight of solids. G is the specific gravity, which is defined as the ratio of unit weight of solids to the unit weight of water. And we have gamma is equal to gamma W into G plus E into SR upon 1 plus E. Gamma is gamma W into G plus E into SR upon 1 plus E. Similarly, dry unit weight gamma D is equal to gamma W into G upon 1 plus E. This is the dry density. Agree? Now we have gamma sat, that is saturated unit weight. What is the formula for saturated unit weight? Anyone, my dear students, please post in the chat box. Gamma sat is nothing but gamma W into G plus E upon 1 plus E. And remember, my dear students, we have gamma D is equal to weight of solids by total volume. Okay. Now, my dear students, we have volume of relations for excavation and borrow pit problems. V2 by V1 is equal to 1 plus E2 by 1 plus E1. And we have submerged unit weight is saturated unit weight minus unit weight of water. See students, whatever I have written in this slide is a very, very important slide, students. If you want to take a photo or anything, please copy these formulas. These formulas, using these formulas, you can challenge me in the GATE exam, in 24 GATE exam. Based on these formulas, whatever I discuss now, there will be a 99% of chances of getting a question. So what is E? Void ratio. Water content is defined as weight of water to the weight of solids. Specific gravity is defined as the unit weight of solids to the unit weight of water. And we have gamma is equal to gamma W into G plus ESR upon 1 plus E. Gamma D is equal to gamma WG upon 1 plus E. And we have gamma sat is equal to gamma W into G plus E upon 1 plus E. And gamma D is defined as weight of solids by total volume. Now, my dear students, what is bulk unit weight? It is the total weight of the soil to the total volume. What do you mean by saturated unit weight? If the voids are completely filled with water, that condition is known as saturated unit weight. What do you mean by dry unit weight? If the voids are completely filled with air, then it is known as dry unit weight. So students, you are eagerly waiting to solve the problems on properties of soil. Say yes or no. Please comment in the chat box. Now let us start the beautiful problem here. I want everyone to involve in the question before going to solve the problem. See students, it's my sincere advice. I will tell you three preliminary steps when you are preparing for GATE exam. For every chapter, prepare a formula sheet. Second thing is, prepare a important formula sheet. After that, you have to prepare a short notes of not more than 1 page. And the third important point is, you have to solve all the previous year GATE questions related to that chapter. Now see, and the most important point, my dear students, whenever you are answering the GATE question, you should read the GATE question very carefully. Now, a soil deposit has a void ratio of 1. A soil deposit has a void ratio of 1. If the void ratio is reduced to 0.6 by compaction, find the percentage of volume loss. This has a meaning, students. Let me tell you, this has a meaning. Now see students, here initial void ratio is how much, sir? Initial void ratio is 1. On compaction, it is reduced to 0.6. Now let me tell you students, initial void ratio E1 is equal to 1. On compaction, it was reduced to 0.6. See students, let me tell you the traditional method and one line answer also. So see students, we know total volume is equal to what, sir? Volume of voids plus volume of solids. What is total volume, my dear students? It is the summation of volume of voids to the volume of solids. So if I take common here volume of solids, it can be written as 1 plus VV upon Vs. So you can write Vs is equal to 1 plus VV upon Vs. On solving this, you will get, because 1 plus VV upon Vs can be written as void ratio. So total volume can be written as Vs into 1 plus E. Am I correct or wrong, my dear students? Swetanshu, please check it again. Okay, here the most important point I would like to tell you, for any given soil, weight of soil is constant and volume of soil is constant. From this relation, we can say that volume is proportional to 1 plus E. Am I correct or wrong, Swetanshu? So volume is proportional to 1 plus E. Varsha, Sai, everyone, are you responding, Amma? So from this relation, we can say that V2 by V1 is equal to 1 plus E2 by 1 plus E1. Directly without this derivation or any concept, you can directly plug in these values. So my dear students, from this you can write V2 by V1 is equal to 1 plus 0.6 divided by 1 plus 1. This can be written as 1.6 upon 2. Yes or no? So V2 by V1 is written as how much, my dear students? 1.6 by 2. Now in this he has asked percentage volume change. So first of all, what do you mean by percentage volume change, my dear students? The percentage volume change is given by the formula V2 minus V1 divided by V1 into 100. See, this is the point they are asking. Okay. Now, but you know already that, my dear students, V2 by V1 is equal to how much we got? 1.6 divided by 2. On both sides, I will subtract minus 1. Okay, or I will subtract 1. Minus 1 is equal to 1.62 minus 1. So here V2 minus V1 divided by V1 can be written as 1.6 minus 2 by 2. This will be equal to minus 0.4 into 2. But he is asking percentage. So I will multiply with 100 and you will get minus 20 percentile. Okay. Swetanshu, please check this. Sai, Srujana, everyone, please check this. So it indicates negative. Here negative sign indicates it is a loss. Here the negative sign indicates a loss. So the answer here is 20%. So my dear students, here the answer is how much, sir? The answer is 20%. Any doubts in this? Sai, Srujana, Swetanshu, okay, Varsha, everyone. Is this answer is clear? The basic funda is it is a loss. Sir, you might taken the formula V1 minus V2 by V1 into 100. But see, usually the change means final minus initial by initial into 100. So minus 20 indicates, minus sign indicates, my dear students, it's a loss. Very good students. Now let me go into the another important question, my dear students. So the question here is, see, please read the question here. A sampler with a volume of 45 centimeter cube is filled with a dry soil sample. When the soil is poured into a graduated cylinder, it displaces 25 centimeter cube of water. What is the void ratio of the soil? For this problem, students, let me tell you the Archimedes principle. What does Archimedes principle says? Suppose if I consider this as a beaker, okay, it has some water in it, okay, and see students, if I place a cricket ball, which the cricket ball is entirely made up of soil. Now if I place this cricket ball in this beaker, how much the volume is occupied by the ball, that much water will be displaced. Okay. So Archimedes principle says that volume of solids will be equal to the what, students? Will be equal to the volume of water displaced. This is a very important. If you know this concept, student, in some cases they might keep kerosene or anything, but you have to compare the unit weights. For now, Rajit Shinde, option D. Rajit Shinde, let me check. Okay, volume of solids is equal to volume of water displaced. So here, volume of water displaced is equal to how much, sir? It is 25 centimeter cube. Okay. Now total volume is equal to how much, Amma? Total volume given in the problem is 45 centimeters cube. So total volume can be written as volume of voids plus volume of solids. So total volume is 45, volume of voids, volume of solids is 25. So volume of voids will be equal to how much, my dear students? It will be equal to 20 centimeter cube. So my dear students, when they ask you void ratio is defined as volume of voids by volume of solids. So what is the value of volume of voids? Anyone, my dear students? What do you mean by, very good Sai Srujana, very good. Volume of voids is given as 20 and volume of solids is 25. So the final answer we have is 0.8. So here someone has asked me the option D. Rajit, very good sir. Rajit Shinde, very good answer. The option here is D, which is equal to 0.8. I see students, what is the key takeaway from this problem? What is the key takeaway from this problem is, you should be aware of the concept of Archimedes principle. Whatever the amount of water or the volume of water displays, that will be equal to the volume of solids. Is this the key point for this question? Yes. So you can remember this key point whenever you see in some other problems, this key point will help you to solve the problem. Very good, Rajit. I am very happy that students are solving the problem and putting their answers. Now let me tell you, a saturated clay has a water content of 39.3 percentile and a bulk specific gravity of how much? Bulk specific gravity of 1.84. The specific gravity of the soil is the void ratio of the soil. They are asking the specific gravity, void ratio of the soil. Now see students, first let me tell you, what is the condition of the soil? The condition of the soil is saturated. Saturated means the voids are completely filled with water. So here, if I see, water content is given by the formula. Water content is given as how much, sir? 39.3 percentile. Okay. Now see students, and we have to know that another important thing is the bulk specific gravity. So bulk specific gravity, GM, in which state, sir? In saturated state. What? See, the mass specific gravity keeps on changing. It is not a constant value like true specific gravity, my dear student. The mass specific gravity changes with respect to the state of the soil. So here it is bulk, it is saturated condition. So gamma sat by gamma W is given by the value 1.84 given in the question. Now my dear students, let me tell you the important concept. We have void ratio is equal to water content to G upon ESR. But what is the condition of the state of the soil, my dear students? The condition of the state of the soil is fully saturated. As it is fully saturated, degree of saturation will be equal to 1, my dear students. So here void ratio E is equal to 0.393 because it is given in percentile. If I convert into the value 0.393 into G. So this is the void ratio because degree of saturation is taken as 1. Now see students, I told you already, gamma sat is given by the formula what, sir? Gamma sat is equal to gamma W into G plus E upon 1 plus E. What is this? Gamma sat is equal to gamma W into G plus E upon 1 plus E. Now please understand this students. Very good Swetanshu. Here I can write that gamma sat by gamma W is equal to what, my dear students? It is equal to G plus E upon 1 plus E. But anyhow, you know what is the value of gamma sat by gamma W given in the question is 1.84. Now just plug in these values. 1.84 is equal to G plus 0.393 G upon 1 plus 0.393 G. So what is the G value you got, my dear students? Can anyone tell me what is the G value you got? Sir, I have plugged in all the values in the problem. We have substituted the first, we have calculated void ratio 0.393 G, and after that we know mass specific gravity, that is 1.84, that is gamma sat by gamma W into G plus E upon 1 plus E. So what is the value you got, my dear students? Anyone, can you tell me what is the value of G? So if you solve this problem, my dear students, you will get G value is equal to 2.74. So have you got this answer, my dear students? So everyone please respond. Sir, Swetanshu, please check it again. You will get a value of 2.74 because you have to take G is equal to 0.393 G. Please check it. You will get a value of G is equal to 2.74. Agree? Now, similarly, what will be the void ratio, sir? Sai, can you respond, Amma? What will be the G value? Another one we have is the E value. E is equal to what, sir? 0.393 into G. So 0.393 into what is the value of specific gravity we got? Here we got is 2.74. So on solving this, what is the value you got? But my dear students, you will get a value of 1.08. So in this problem, let me try what they have asked you. Sir, first problem they have asked what is specific gravity. So the option here is C, okay, 2.74. And the next option void ratio is 1.08. Very good, Swetanshu. Very good. Very good, sir. Now, see, student. This is the continuation of that problem also. Sorry, not continuation. We have another problem, sir. Now, what is the next problem we have is, sir, I told you again and again, whenever you are solving the gate question, it's my sincere advice that you should read the question very carefully. What is the given data? What can be the relations with that given data? If you can analyze this simple logic, it would be better to solve the problem. So see, students, a soil has a porosity of 40 percentile, G is equal to 2.5 and water content is 12 percentile. One will be the calculate the water content at fully saturation. So my dear students, let me tell you what is the porosity, sir. 40 percentile, specific gravity is 2.5 and the water content is 12 percentile. So he is asking what is the water content for fully saturation. Very good, very good. Now see, sir, that is the first question, right? So here, please understand, porosity is given as 40 percentile, my dear students. What is the value of porosity? We have 40 percentile. And specific gravity is given as how much, sir? 2.5. Specific gravity is equal to 2.5. And water content is how much, sir? 12 percentile. What is the weight of water required for fully saturation? He is asking what is the weight of water required for fully saturation. So see, students, what they are asking is how much amount of water is required for fully saturation. For this, see, students, see what they have given you, water content at fully saturation. They are asking what is the weight of, not weight of water, sir. They are asking what is the water content, not weight of water. They are asking what is the water content for fully saturation. So see, students, you know the relation between void ratio, specific gravity, degree of saturation and water content. Sir, these are the four terms. Using these four terms, what is the relation we have? Relation we have developed is E is equal to water content to G upon SR. Am I correct or wrong, my dear students? Here E indicates the void ratio, WC indicates the water content, and G is the specific gravity, and SR is the degree of saturation. Very good, Swetanshu. Now, how to find out E? You know already the relation between porosity and void ratio is taken as E, N is equal to E upon 1 plus E. Now, what is the porosity value they have given? It is given as 40 percentile, or you can write it as 0.4. So, if I substitute the value of 0.4 is equal to E upon 1 plus E, on solving this, you will get E value is equal to how much, sir? 2 by 3, or you can write 0.67. So, you have got the void ratio is how much, sir? 0.67. So, here see, student, void ratio is equal to 0.6 is equal to water content for fully saturation into 2.5 divided by degree of saturation is how much, sir? For fully saturated soils, my dear students, the degree of saturation is equal to 1. So water content can be taken as 0.67 divided by 2.5. So what is this value? Can anyone tell me? What is this value, sir? 0.67 divided by 2.5. What is that value, sir? If you solve this, you will get a value of 0.268 or you will get a 26.8 percentile. Am I clear, sir? Have you got this? Very good, very good. So here if you see the first option, here it is 20.6 or option B will be correct, sir. So what is the water content which will fully saturate the soil sample is 26.6 percentile. Very good answers, very good, sir. Sir, students, whenever you are trying to join the online session, try to be interactive. Try to post the answer. Whether it is a correct or wrong, we are least bothered. But you should understand the ground principality. You should practice that problem. So the next question we have is what is the weight of water required to be added for 100 meter cube of soil for fully saturation? This is a beautiful question, my dear students. Let me tell you, this is a beautiful question. We have, what is the weight of water required? Weight of water required to be added. Sir, this has a huge meaning, I will tell you. Weight of water required to be added. This has some meaning, sir. That is the reason I am highlighting this. What do you mean by required to be added is a very important term. So the volume here is given as 100 meter cube. Volume is given as how much, sir? 100 meter cube. Now he is asking what is the weight of water for fully saturation. Sir, remember my dear students, for fully saturation, always remember that degree of saturation is equal to 1. So let me tell you the question again. How much amount of water is required to be added? Added has a very much important significance. Required to be added for fully saturation. Now see students, the water content for fully saturation, just now we have calculated the water content for fully saturation is how much, my dear students? Just now in the problem A, we have calculated that it is equal to 0.266 or 0.268. Anything is fine. So you have calculated the water content for fully saturation. They have given water content initially is how much, sir? 12 percentile. So this will be equal to 0.12. But let me tell you, he has asked in the problem, what is the weight of the water? So he is asking what is the weight of water. My dear students, let us go into the granularity. What do you mean by water content, sir? What do you mean by water content? Water content is defined as weight of water upon weight of solids. Am I correct or wrong? The basic definition of water content is what, sir? Weight of water upon weight of solids. So let me tell you, weight of water is equal to water content into weight of solids. Am I correct or wrong, my dear students? So weight of water can be written as water content into weight of solids. Now, how do you write weight of solids? See students, here we have dry density is equal to weight of solids upon total volume. What is dry unit weight? My dear students, it is defined as weight of solids upon total volume. Very good, sir. And weight of solids can be written as gamma D into volume. Weight of solids can be written as weight gamma D. Gamma D is what, my dear students? It is nothing but the dry unit weight. So dry unit weight into volume is nothing but weight of solids. Now see students, as he has told in the problem, weight of water required to be added. Already there is some water for a water content of 12%. For a water content of 26.6, you are getting for fully saturation, the water content is 26.6. For the water content for fully saturation, you have to write weight of water required to be added. Please remember this formula, students. Weight of water required to be added is given by the formula weight of solids into water content 1 minus water content 2. See students, here you can ask me, Sir, which one I have to take? Either water content one has, sir, simple logic is which value, whether 12% has one water content 1 or 26.6% has water content 2. The logic is simple. Whichever is higher, you can take that as water content 1. And weight of solids can be written as what, my dear students? Gamma D into volume into water content 1 minus water content 2. So we have come up with the final formula. The weight of water required to be added is gamma D, dry unit weight, into volume into the difference between the water contents. Now how do you calculate? Swetanshu, please check it again. How do you calculate gamma D? Gamma D is given by the formula gamma W into G upon 1 plus C. What is the basic, very, very important formula? The dry unit weight is given by the formula gamma W into G upon 1 plus C. So here you can write it as gamma D. Sir, I will take it as 1 ton per meter cube, gamma W. And let me tell you, see students, gamma W value, if it is in kilonewton per meter cube, 9.81 kilonewton per meter cube. If it is in ton per meter cube, it is 1 ton per meter cube. Or if it is in gram per cc, it will be 1 gram per centimeter cube. So these are the standard values of unit weight of water. So if I solve this, specific gravity is given as 2.5 and the void ratio we got is how much, sir? 0.66 or 0.67. On solving this, dry unit weight can be taken as 1.5 ton per meter cube. Sir, people will ask me, sir, why you have done 1.5 ton per meter cube, sir? Why can't it be 1 gram per cc? The logic is simple, amma. Because the volume is given in meter cube. So I have taken 10 per meter cube, ton per meter cube. Sir, you can take 9.81, but 9.81 the calculation will be more. And also in the solution, in the options they have given in tons. So I have taken 1 ton per. So dry unit weight, now I will plug in these values here. So dry unit weight is 1.5. Volume is how much, students? They have given in the problem. It is 100 and the water content for fully saturation is 0.266 minus 0.12. So here you will get 150 and 0.146. If you solve this, students, you will roughly get how much, sir? You will roughly get the 22 tons. So the weight of water will be how much, sir? 22 tons. Is this clear, sir? So my dear students, so what is the answer we have? Option C. So C, students, what they have asked you in this problem is, what is the weight of water required to be added to 100 meter cube of the soil for fully saturation? Now see, student, for fully saturation what I have done? Sir, see, weight of water required to be added, volume is 100 meter cube. I have told you weight of water can be written as water content into weight of solids. And weight of solids can be written as dry unit weight into volume. And weight of water required to be added is given by the formula added kms. That is the reason I have the difference between the water contents, and we have finded the gamma D value and we have got the volume and everything. And just plug in these values into the formula and we have got the answer. So students, are you enjoying the session? Just like it and share to your friends who it will be really helpful for them who want to solve the questions. If they are already done with their concepts and they want to test themselves with the classical problems, then they can test themselves. So students, if you are feeling it was good, you can share to your friends who are interested. Okay. Now the third question we have is please read this question, students. The water content which can fully saturate and increase the volume by 5%. See, this is very, very important, my dear students. The water content which can fully saturate and increase the volume by 5%. So, initial volume is how much, sir? 100 meter cube given in the problem. Yes or no? Am I clear or not, sir? Initial the water content volume is 100 meter cube. And remember we got void ratio E1 is equal to how much? 0.67. Yes or no? So I told you already, in the second case, volume is increased by 100 plus 5% of 5% means 5 by 100 into 100 meter cube. So it is nothing but V2 is equal to V1 plus 5 percentile of V1. So we got 100 plus 5. So this value will be equal to 105 meter cube. Am I 105 meter cube? Now in this case, what will be the void ratio? Until unless you know the void ratio, if you know the void ratio, it would be easy to calculate the water content. So my dear students, here I can write V2 by V1. Here you can write, my dear students, V2 by V1 is equal to 1 plus E2 by 1 plus E1. Am I correct or wrong? So what is the V2 value you got? 105, and you don't know the value of E2. So let us find out. V2 is equal to 105 divided by 100 is equal to 1 plus E2, I am not aware, divided by 1 plus E1, that is 0.67. So what is the value of E2? Anyone, my dear students? Can you quickly comment what is the answer for E2? Sir, you will get a void ratio of E2 is equal to how much, sir? Void ratio of E2 is equal to 0.743. Have you got this value, sir? Have you got this value? Very good, very good. So, after finding the value of void ratio, you know again, void ratio is equal to water content to G by SR. But he is asking, what is the water content for fully saturation? For fully saturation, degree of saturation will be equal to 1. So, water content is equal to E by G. So, E is equal to 0.743 divided by 2.5. So, what is the value you got, my dear students? Rajit Shinde. Very good, sir. Rajit Shinde. Very good. What is the answer you got? What is the answer you got? Water content. You will get a water content of around 0.2972, or which is equal to 29.7%. Okay. So let me see the question. So 29.7 percentile means the option will be 30%. So I hope you are clear with this question. Now again I want to, Rajit Shinde, very good sir, very good, very good. Rocky, good morning sir, good morning Rocky. Okay, now see students, let me tell you one important thing. So what is the key takeaways from this point, from these problems? What are the key points? The key points in this problem are the weight of water required to be added. When the word added is come, you have to find the difference in the water contents. And weight of water is given by the formula water content to weight of solids. So let me tell you, weight of water required to be added is given by the formula gamma D into V into water content 1 minus water content 2. Here water content 1 means whichever is the highest one. The second key takeaway from this problem is V2 by V1 is equal to 1 plus E2 by E1. This is the second formula. And the third important and the basic formula is void ratio E is equal to water content to G upon SR. So students, it's my sincere request, whenever you are solving the problem, I've been repeating this for a couple of times. The important thing is, if you write the key takeaways, whenever you are solving the next problem of this kind, it would be very easy. Very good sir. I'm really happy with the students. You are responding with the right answers. Okay, now let me tell you the important concept. So see students, the correct increasing order of the specific surface area. So actually see students, this question is related to the soil structure. This question is related to the soil structure. Okay. Now what do you mean by soil structure? The geometrical arrangement of the soil particles is known as soil structure. Now immediately Sai or Rajit Shinde will ask me, sir, why do you want to understand the soil structure? The soil structure we are trying to understand with the simple logic that the behavior of the soil depends upon soil structure. The important concept in soil structure is clay mineralogy. It is a theory kind of question, but I will give you some insight about this where we have expected a previous gate question. So we are talking about clay mineralogy. What do you mean by clay mineralogy is we have mainly three minerals. One is the kaolinite. Name the clay mineral which is the most stable clay mineral. They can ask you, name the clay mineral which is the most stable clay mineral. The most stable clay mineral is nothing but kaolinite. And how do you say that the mineral is most stable, my dear students? We can say that the mineral is most stable when it has no swelling and no shrinkage. Next question is, name the clay mineral which is formed by, very good Swetanshu, name the clay mineral which is formed by potassium ions. The answer is simple and it was a previous year gate question. The answer is elite. Name the clay mineral which is the most unstable clay mineral, or name the clay mineral which is formed by water molecules. Then the answer here is montomonolite. It is the most unstable mineral. Why it is most unstable mineral, my dear students? Because it has more swelling and at the same time it has more shrinkage. That is the reason. Okay. Now, my dear students, here in this concept, they are asking about specific surface area. Sir, this is the common question everyone I ask in every class usually. Sir, you should know what is the difference. Sir, they can ask you, what is the area of rectangle? Area of rectangle is L into B. What is the surface area of rectangle? Area and surface area will be same for two-dimensional bodies. Sir, I have observed in so many classrooms, like in this 10 years of experience, people are just have to understand the basic conceptual. That is, the surface area and area for two-dimensional bodies, it will be same. Now, why do you want to study about specific surface area? Very good, sir. What do you mean by specific surface area? Specific surface area means it is the surface area of, what is specific surface area, sir? It is the surface area of, soil particles. It is the surface area of soil particles. It is the surface area of soil particles present in, it is the surface area of soil particles present in unit weight. Agree? So, what is specific surface area? It is the surface area of soil particles present in unit weight. So, the units will be area per weight. So, it can be centimeter square per gram or meter square per gram or anything. Now, let me tell you one important thing. Sir, even in cement also you study about specific surface area. Higher the soil, higher the specific surface area. This is a very important statement. Why, sir? Finer the soil. If the soil is finer the soil, you have to remember, this is the key takeaway from this, sir. Finer the soil, higher the specific surface area. Finer the soil, higher the specific surface area. Because see students, usually the size of the void is very less in fine grain and size of the void is more in coarse grain. Now from this relation, we have come up that SSA means specific surface area is inversely proportional to the particle size dia square. What is specific surface area? Specific surface area is inversely proportional to particle size dia square. Am I clear, sir? So remember this logic and this logic. Finer the soil, higher the specific surface area, and specific surface area is inversely proportional to particle size dia. And remember, sir, why monolite has high swelling and shrinkage is it has the highest specific surface area. That is the reason it has high swelling and shrinkage. Now see students, now there was a question asked, the correct increasing order of the specific surface area. So you already know the logic. Finer the surface, finer the soil, higher the specific surface area. So what does the statement says? Finer the soil, higher the specific surface area. If the particle size is less, then it will have more specific surface area. If the particle size is more, then it will have the less specific surface area. So if you see the order also in particle size, it is like if I talk gravel, after gravel you have sand, and after sand, my dear students, you talk about silt, and after silt you talk about clay, and after clays you talk about colloids. So now see students, if they are asking the increasing order, so first least will have sand, after sand you will have silt will have more than sand, and after silt will have more than clay, and clay will have more than colloids. And the key takeaway from this is the colloid particle sizes, option D. No, option C, sir. Rajit Shinde, please check. I think you are, sir, finer the soil, higher the specific, sir. Colloids is the finer soil. Very good, very good. So here what I would like to tell you, the key takeaway from this point is finer the soil, higher the specific surface area, or you can say specific surface area is inversely proportional to the particle size dia square. Very good, sir, very good. Now see students, please read this question, and it was one of the previous year gate question. From a laboratory investigation, the liquid limit, plastic limit and natural moisture content and flow index of a soil specimen are so and so. What is the corresponding toughness index and liquidity index? Now let me tell you one important concept, Amma. Sir, see, actually we called consistency limits, and we also have one is consistency limits. Can anyone tell me, sir, what is consistency limits? Consistency limits are also known as what, sir? Atterberg limits. Consistency limits are also called what? Atterberg. Consistency limits are also called as Atterberg limits. Now see students, let me tell you the important. If you can see this graph, you will get a clear idea. Okay. Just give me a second. Now see, here let me tell you the concept, sir. What is the concept here is, see, if I consider this as a graph, what here is, if I draw a graph, okay, this is known as dry volume, okay, this is known as shrinkage limit, and this is known as plastic limit, this is known as liquid limit, and here the volume at plastic limit is taken as Vp, and the volume at liquid limit is taken as VL. Now see students, from a layman, if I don't know anything about civil engineering, I can, looking into the graph, I can understand one important point, that liquid limit is always greater than plastic limit, and plastic limit is always greater than shrinkage limit. So can I write like this, students? So here liquid limit is greater than plastic limit, and plastic limit is always greater than shrinkage limit. So this is a very, very important relation. Remember, my dear students, liquid limit is greater than plastic limit and plastic limit is greater than shrinkage limit, because as you move towards the right side, the higher the values, right? So this one. Now above the liquid limit we call it as liquid state. This is liquid state. This is plastic state. This is plastic state. This is semi-solid state. This is semi-solid state. And this is solid state. So why I have told this is, see students, when the water content is trapped between shrinkage limit and plastic limit, then the state you should be aware, it is semi-solid. If the water content is trapped between plastic limit and liquid limit, then it is plastic state. More than liquid limit, it is liquid state. You should be aware of these things, students. So let me tell you what is liquid limit. Liquid limit is nothing but it is the minimum water content where the soil, or it is the minimum water content at which the soil has small shear resistance. Once it crosses the liquid limit, it will not have any shear resistance and it behaves like a liquid. So you can say it is the critical point for the liquid state. Plastic limit means, what do you mean by plastic limit? See, the practical definition is the minimum water content at which if you add some water into the soil and you make like a rope of 3 mm diameter, it should not break. So again I am telling, it is the minimum water content at which the soil can be rolled into 3 mm diameter without breaking is known as plastic limit. Now let me tell you what do you mean by shrinkage limit. Shrinkage limit means it is the minimum water content at which the soil is fully saturated, or other thing, please see the graph, it is the maximum water content up to which any loss of moisture, this is very important observation. Up to shrinkage limit there is no change in the volume. After shrinkage limit the volume changes linearly. That is the important point I would like to tell you. So what is shrinkage limit means? It is the maximum water content up to which a soil, means any further loss of moisture does not cause any change in the volume. That is known as shrinkage limit. I hope you are clear. Very good, sir. Now see students, apart from this, let me tell you the indices. Actually these indices are very much helpful for understanding the behavior of the soil. And to classify the soil, these indices are very important. What do you mean by indices here? The first one we have is the plasticity index. Plasticity index is given by the formula liquid limit minus plastic limit. What is plasticity index? Plasticity index is given by the formula liquid limit minus plastic limit. And remember, shrinkage index is given by the formula WP minus WS. Plastic limit minus shrinkage limit. I hope you are clear. Okay, what is IP, sir? Plasticity index. What is IS? Shrinkage index. And we have IT. IT is nothing but the toughness index, which is given by the formula IP upon IF. Sir, what do you mean by IF? Actually, the slope of flow curve. The slope of flow curve. What is the slope of flow curve? The slope of flow curve is nothing but the toughness index. So, flow index IF is given by the formula W1 minus W2 upon log N2 upon log N1. So, this is the toughness flow index. Clear, sir? And we have liquidity index IL is equal to W. What is W, sir? Natural moisture content minus WP, plastic limit, upon IP, that is called as plasticity index. So liquidity index is given by the formula W minus WP upon IP, and tough consistency index is given by the formula WL minus W upon IP. And the most important point I would like to tell you here is IC plus consistency index plus liquidity index is equal to 1. What, sir? You have to see that. Very good Swetanshu. log n1 minus log n2. If you take n2 is the maximum value, then it will be log n2 minus log n1. And remember, log a minus log b can be written as log a upon log b. Okay, I hope you are clear. So these are the important formulas when you are solving the problems on the soil classification or index properties. You should be aware of this. Even plasticity chart also I will be explaining you. Now see students, they have given, now let me check what they have given. The liquid limit is how much, sir? Liquid limit is 60 percentile and plastic limit is how much, sir? 20 percentile, 27. Moisture content is how much, sir? 32 percentile and flow index is 27 percentile. So let us write the given values here. So let us write the given values. What is, can anyone tell me what are the given values, sir? Liquid limit is how much, sir? 60. See students, here liquid limit is how much, amma? Liquid limit is 60 percentile. Yes or no? Liquid limit is 60 percentile. And we have plastic limit. We have how much, sir? Plastic limit is how much? 27. Plastic limit is 27. Moisture content is 32 percentile. Plastic limit is 27 percentile. Moisture content means water content. Water content or W. You can write W is how much, sir? 32 percentile. And flow index is 27 percentile. What he has asked in the problem, he is asking what is the value, sir? What he has asked in the problem? He has asked in the problem what is the toughness index and what is the liquidity index. Okay. Now see students, he is asking the problem what is IT. IT is just now I told you, which is known as toughness index, and what is IL, that is liquidity index. Now see students, let me tell you the thing. What do you mean by toughness index, sir? IT is nothing but toughness index. So what do you mean by toughness index, my dear students? Toughness index is given by the formula IP upon IF. Okay. Toughness index is given by the formula IP upon IF. Here what is IP, sir? IP is nothing but, you can say here, liquid limit minus plastic limit divided by IF. Okay, let me calculate plasticity index. Plasticity index is IP is equal to 60 minus 27, that is liquid limit. You can write here liquid limit minus plastic limit, which is equal to 33 percentile. So see students, here it is how much, sir? 33 percentile divided by flow index is given as 27 percentile. So what is this value? Can anyone tell me, sir? What is this value? What is this value you got? 5.4, 32.4. So it will be around 1.22. Have you got this value, sir? Because 27 into 0.2, 5.4, 32.4. Another 0.54 is 0.02. So you will get 0.94. It will be around 1.22. Have you got this answer, my dear students? Have you got this answer? So here what is the toughness index, my dear students? The toughness index is given by the formula WL minus WP upon IF. Here that is 33 percentile divided by 27. Very good, 1.22. Very good, sir. After solving this, we have liquidity index. Liquidity index is given by the formula W minus WP upon IP. What is water content, sir? What is the water content here? So what is the water content, student? Water content is nothing but 32 percentile. Water content is nothing but 32 percentile. And what is plastic limit, sir? 27 percentile. Upon what is IP, sir? IP you got, what is the value you got? 33 percentile. So 5 divided by 33. 5 divided by 33 is around how much, sir? How much you got? 5 divided by 33. Anyone, my dear students, what is the value of 5 divided by 33? 1 by 6, 1 by 0.6, 1 by 6.8, 6.6. So it will be 0.15. So liquidity index is how much, students? It is equal to 0.15. And we have, what is the value of, toughness index? It is 1.22. So let us check the values. So what is the option we have, sir? Toughness index is 1.22 and liquidity index is 0.05. So the option B is correct. Is this clear, students? So what are the key takeaways from this problem? So in this problem, you should be aware of the indices. One is the plasticity index, that is liquid limit minus plastic limit. Another one is flow index, that is a graph is drawn between water content and the number of blows. So it is given as W1 minus W2 upon log of N2 by N1. Agree? And the toughness index is given by IP by IF. What is IP by IF? Plasticity index upon flow index. And liquidity index is given by the formula W minus WP upon IP. And the plasticity index is WL minus WP. And consistency index is WL minus W upon IP. Remember, my dear students, why you are learning about the indices is to classify the soil, whether it is a fine grained or a coarse grained, and again in fine grained, whether it is a clay or a silt. These indices will be very helpful. I hope you are clear. Okay. Let us quickly go into the next question. I would be very happy, sir. I'll just give you a minute. Just read the question. I'll read the question for you. The plastic limit and liquid limit of a soil are 33 percentile and 44 percentile respectively. The percentage volume change from the liquid limit of the dry state, from liquid limit to the dry state is 36% of dry volume. Similarly, the volume change from plastic limit to the dry state is 24%. Calculate the shrinkage limit and shrinkage ratio. Students, just give a try for, I'll give you just 2 minutes. Okay. Just give a try this problem, students. Very good, very good. Sir, see, whenever these kind of problems are given, I just give you the important concept, sir. As I told you, when I draw a graph between, I'll draw a graph between volume and the water content. As you know already these values. Okay. This value is called shrinkage limit. This value is called plastic limit, and this value is called liquid limit. And here I will take this as volume at liquid limit, volume at plastic limit, and here is the one we have dry volume. Okay. Now see, students, here in this problem, let me tell you in this problem, the plastic limit and liquid limit are how much, sir? Plastic limit is 33 and liquid limit is 45. So plastic limit is how much, sir? It is 33 percentile. And liquid limit is how much, sir? 45 percentile. What is liquid limit, amma? Liquid limit is 45 percentile. Plastic limit is 33 percentile. Okay. Next point is the percentage volume change from liquid limit to dry state is, from liquid limit to dry state, this volume change. Whatever the volume change from liquid limit to dry state is given as 36 percentile of dry volume. Sir, this was given in the problem that the volume change from liquid limit to dry state is how much? It is 36 percentile of dry volume. Okay. Similarly, see, student, similarly the percentage volume change from plastic state to dry state is 24 percentile. So from plastic state to dry state, it is how much, sir? If you consider this change, this is 24 percentile VD. Okay. So see, students, volume change from this is 36 percentile VD. And what is the volume change from plastic state to dry state, sir? VP minus VD is equal to how much, sir? The volume change from plastic state to dry state is how much? It is equal to, what is the value? It is equal to 24 percentile of VP. Now see students, what will be the volume change from liquid limit to plastic limit means just subtract those two values, you will get 12 percentile VD. So these are the volume change. Now see students, in this problem what they are asking is, first thing is shrinkage limit. Now how do you calculate shrinkage limit is, this is a, you have to find out the slopes. The slopes will be same. So here how to find out the slopes, you will be doing this. So how to find out the slope students? The slope here I will tell you. Here how can you find out? Sir, slope means y2 minus y1 by x2 minus x1. So can I write VL minus VP is equal to WL minus WP. Are you getting me, sir? So this slope, this distance upon this distance. Now this distance upon is equal to VL minus VD upon WL minus WS. Sir, what I have done is, the difference in volume change will be the, we have to consider the difference in volume change to the corresponding change in the water content. So what is VL minus VP? 12 percentile of VD. This is equal to 12 percentile of VD, and WL minus WP, it is also 45 percentile minus 33 percentile is equal to VL minus VD. What is VL minus VD, sir? That is equal to 36%. That is equal to how much, sir? 36 percentile of VD. That is equal to liquid state, liquid limit is how much, amma? 45 minus WS. So here this VD will be cancelled. If you solve this, if you solve that, WS will be equal to, how much we got, sir? 45 and 36. 45 percentile minus 36 percentile. That will be equal to 9 percentile. So what is the value of shrinkage limit? The value of the shrinkage limit is how much, sir? What is the value of shrinkage limit? It is equal to 9 percentile. But he has asked, what is shrinkage ratio? Sir, see, first of all, let me tell you, what do you mean by shrinkage ratio? Sir, see, as I told you, if you see the graph here, what do you mean by shrinkage ratio means? See, it is the volume change expressed in terms of dry volume to the corresponding change in water contents. What is shrinkage ratio, sir? It is the ratio of volume change, VL minus VP, volume change in terms of dry volume to the corresponding change in water content. Let me tell you again, shrinkage ratio is defined as the volume change expressed in terms of dry volume to the corresponding change in water contents. So what is volume change, sir? VL minus VP. What is VL minus VP? They have given VL minus VP is 12% VD. So 12% of VD divided by VD upon WL minus WP. So 45 minus 33 percentile. So if you solve this, this will be equal to 1. So here what will be the answer, sir? The answer, first answer you got 9 percentile and the second answer we got is 1 percentile. So what are the answers we got? Shrinkage limit is 9 percentile and the shrinkage ratio is how much, sir? 1. So see students, let me tell you the thing. Shrinkage ratio is defined as the volume change expressed in terms of dry volume to the corresponding change in water content. And remember, liquid limit is always greater than plastic limit greater than shrinkage limit. And remember, the slope will be the same. How you calculate slope is difference in y coordinates upon difference in the x coordinate. Another important thing you can directly note is shrinkage ratio is defined as the mass specific gravity at a dry state. This is a very important point, students. So simple, directly you can write shrinkage ratio GM can be written as gamma W by gamma W at a dry state. This specific gravity can be written as SR. SR means shrinkage ratio. So you can also take this key point, Amma. The mass specific gravity at a dry state will be equal to the mass specific gravity at dry state will be equal to what, sir? Will be equal to the shrinkage ratio. Is this clear, my dear students? Is this clear? So students, as you are in the first stage, you are not showing that much enthusiasm. Now Varsha and all, Vaishnavi, Varsha, Swetanshu or Rajdit, when you are trying to get the concepts, try to keep a note of the key points. Okay. So let us enthusiast ourselves with the next question. See students, this is a question, very good sir. This is a question related to the soil classification. Now when I talk about soil classification, before reading that question, Amma, I just want to tell you some important things. When I talk about soil classification, we have two important things, sir. In soil classification, what we have? We have the two important things. One is the fine-grained soils. What soil classification, what we have, sir? One is the fine-grained soils, and other one we have is the coarse-grained soils. Okay. So how do you say it is fine-grained? Is if more than 50% is passing through 75 micron sieve, then it is called fine-grained soils. Okay, here you can say 50% passing. Okay, if less than 50%, then it is coarse grain. What are fine-grained particles? Can anyone tell me? Clay and silt. What are fine-grained particles, students? Clay and silt are nothing but the fine-grained particles. What are coarse-grained particles? Coarse-grained particles are nothing but gravel. Coarse-grained particles are nothing but what, sir? Gravel and sand. So here please try to understand, the fine-grained particles are nothing but clay and silt. If more than 50% is passing through the 75 micron sieve, we call it as fine-grained. If more than 50% is retained on 75 micron, then it is coarse-grained, gravel or silt. Now see students, to say whether a soil is well graded or poorly graded, there is some coefficients. So in that coefficients, the first one we call it as coefficient of uniformity, which is defined as D60 upon D10. What is Cu, sir? Cu is defined as D60 upon D10. Okay, this is known as coefficient of uniformity. So what do you mean by coefficient of uniformity is, it gives the particle size range from which, if you consider a sieve, to have an idea of the particle size range, you should understand the coefficient of uniformity. And remember, my dear students, for a well graded gravel, Cu should be greater than 4. Okay, for well graded gravel, Cu should be greater than 4. And remember, my dear students, for well graded sand, Cu should be greater than 6. So what is Cu? It is defined as the ratio of D60 by D10. Sir, see students, here D10 is known as effective size. This is another important point. What is D10, sir? D10 is nothing but the effective size. And see students, what actually do you mean by D10 is? D10 is nothing but where it is the size of the sieve, where 10% of the soil particles are passing. When you say 10% of the soil particles are passing, that sieve only is considered as effective size. If it is D60, then we call it as where 60% of the soil particles are passing. And we similarly have coefficient of curvature. Coefficient of curvature is given by the formula Cc is equal to d square 30 upon d60. It is given as d square 30 upon d60 into d10. So this is the formula for what, sir? Coefficient of curvature. So why do you want to study about the coefficient of curvature? See students, how the graph look like. Okay, the shape of the curve. Sir, see, actually what happens is, if you see the graph, percentage finer, if I talk about the percentage finer and particle size, the graph will be looking like this. Just to have an idea, I am giving you students, and quickly, the percentage finer and particle size for L graded it will be like this, for uniformly graded it will be like this, for poorly graded it will be like a hump shape. So the shape of the curve depends upon coefficient of curvature. So the coefficient of curvature is given by the formula d square 30 upon d 60 into d10. For well graded soils, CC value should lie between 1 to 3. If the value of coefficient of curvature is between 1 to 3, then we say that soil is well graded. So again, my dear students, for any soil to be well graded, this is the important point, the conditions of both CU and CC should be satisfied. For a soil to be well graded, what, my dear students, both the conditions of CU and CC should be satisfied. Now let us see the questions. Sir, see, please read this question carefully, students. A laboratory sieve analysis was carried out on a soil sample using a complete set of standard IS sieves. Out of 600 grams of soil used in the test, 240 grams was retained on 600 micron, 240 was retained on 600, and the 300 grams was retained on 500 micron sieve, and the remaining was retained on 425. Calculate the coefficient of uniformity and classify the soil. So let us start this problem. Okay. So I hope he is asking the value of coefficient of uniformity. So see students, first one we have is, first whenever these kind of questions are asked, please write the sieve analysis table. First one is, first column is sieve size. First column is what, sir? Sieve size. Next column is what, sir? Weight retained. Second column is weight retained. And the third column is percentage weight retained. What is the third column, sir? First column is sieve size. Second column is weight retained. And third column is percentage weight retained. Next one is cumulative weight retained. Cumulative weight retained. And the last column is percentage finer, or we call it as passing. Okay, this is the table you should be aware. What is the first column? Sieve size. Second column is weight retained. Third column is percentage weight retained. Third column is cumulative weight retained. And the final column is percentage finer and passing. Now, my dear students, first sieve size. What is the first sieve size, sir? IS 600 micron sieve. How much weight retained it is? He told 240 grams. And in IS 500 micron sieve, it is how much, sir? 500 micron sieve. It is 300 grams. Okay. And you know, see students, here I would like to tell you one important thing. What is the total weight, sir? What is the total weight here? What is the total weight is? Total weight is nothing but 600 grams. What is the total weight? Total weight is 600 grams. Okay. Now, when I talk about IS 425 micron, so what is the total weight, sir? So you can write total weight is 600. So total is 600. So 600 minus 240 minus 300, you will get IS 400 micron series, 425 microns is 60 grams. So how do you find out percentage weight retained, madam? Sorry, students, it can be written as W. If I take this one as W, W1 into total weight into 100. So can I write it as 240 by 600 into 100? So this is equal to 40 percentile. What is this value, sir? 6 to 40, 40. If it is 300, so here you can write 300 divided by 600 into 100. So this is equal to how much, sir? This is equal to 50 percentile. Agree, my dear student? Last one we have is 60 divided by 600 into 100. So this is equal to 10%. So we have got, sorry student, we have got the weight retained as 40, 50 and 10%. So cumulative weight retained is how much here, sir? Here it is 40 percentile. So here it will be 40 plus 50. This will be equal to 90 percentile. And here 90 plus 10. This will be equal to 100 percentile. What is these values? 40, 90 and 100. These are the cumulative weight retained. But what we have to find out? Percentage finer. So percentage finer is given by the formula 100 minus 40, which is equal to 60 percentile. So just remove these values from 100 or subtract those values. 100 minus 90 is equal to 10 percentile. And 100 minus 100 is 0%. Now, I told you one important thing, students. This is a very important thing. What is IS 600 micron sieve? See, here they have given you the passing value. Sir, see, remember, most of the students are aware or you might be confused in one important point. What do you mean by D60 or what do you mean by D10 or what do you mean by D30? First of all, D30, D60, D10 or anything, my dear students, these three are nothing but the particle sizes. Am I correct? See, Varsha, Swetanshu and Sai Srujna. Are you following? And Rajit. So here I would like to tell you the 60% indicates D60 means first of all it is sieve size. So here, see students, I can say D60 is equal to size of the sieve is IS 600 micron sieve. Similarly, if I talk about D10, here in D10 we have IS 500 micron sieve and this value is equal to 10%. So here, my dear students, D10 will be equal to how much, sir? D10 will be equal to IS 500 micron sieve. So you know the value of D60, you know the value of D10. So how to find out the coefficient of uniformity, sir? Coefficient of uniformity is given by the formula D60 upon D10. So what is the value of D60? It is nothing but 600 micron. So here 600 micron divided by D10 is 500 micron. So this value will be equal to 1.2. So what is the value of Cu, my dear students? Very good, Swetanshu and Sai. So what is the value of Cu, sir? Cu value is given as 1.2. Now let me tell you another important thing. Let me tell you. Sir, see, if you see the sieve sizes in the, 600 micron, 500 micron and 425 micron. So what are these sieve sizes, sir? 600 micron can be written as 0.6 mm. 500 micron can be written as 0.5 mm and 425 micron can be written as 0.425 mm. And remember, see students, by looking into the sieve sizes, sir, let me tell you about sieve sizes also here. If you consider it is 2 micron, less than 2 micron, we call it as clay. And if it is less than 75 micron, we call it as silt. And 75 micron to 4.75 mm, we call it as sand. And 4.75 mm to 80 mm, we call it as gravel. Okay, this is mm, students. 4.75 mm to 80 mm, it is gravel. And we have 300 mm. Up to 300 mm, this is called cobble. And more than 300 mm, we call it as boulder. So you should have an idea of this. So see students, if you see the particle sizes or sorry, if you see the sieve sizes here, the sieve sizes are clearly in between. 75 micron means 0.075 mm. Okay. So the sizes are clearly lying between 0.075 mm and 4.75 mm. So the answer will be sand. So how do you classify this soil is? The soil is definitely sand. But how do you say that soil, sand, whether it is well graded or poorly graded? See students, here I have written Cu value is how much, sir? Here I have written Cu value is equal to 1.2. For a well-graded sand, Cu is not greater than 4. So it is not well graded. So the answer will be poorly graded. Are you getting me, sir? For a well-graded soil, Cu should be greater than 4. Sorry, 6, sir. Sorry, students. Please make a correction here. For well-graded sand, Cu should be greater than 6. But what is the value you got? Cu you got 1.2. So definitely it is a poorly graded sand. So let us see the answers here. The first answer, the coefficient of uniformity of the soil is 1.2. Okay, this is the answer we have. 1.2. It is an NIT question. And the classify the soil is option A, poorly graded sand. It is not gravel or sand. It is definitely a sand. In that sand, whether it is a well graded or poorly graded. So what are the key takeaways from this problem? Can you tell me, students? The key takeaways from these problems are two things. Coefficient of uniformity is defined as D60 by D10. D10 is the effective size, or it is the size of the sieve where only 10% of the soil particles are passing. Next one we have is the coefficient of curvature. It is D square 30 upon D60 into D10. That is called coefficient of curvature. Now, once you find out coefficient of uniformity and coefficient of curvature, next thing what I would like to discuss here is the most important point. How do you say the sieve analysis? First you have to calculate the sieves. First they will be giving the sieve sizes, then weight retained, percentage weight retained, cumulative weight retained. After cumulative weight retained, 100 minus cumulative value will give you the percentage passing or percentage finer. And for a soil to be well graded, it should satisfy both the conditions of Cu and Cc. For well graded sand, Cu should be greater than what, sir? For well graded sand, Cu should be greater than 6. And for poorly graded, any value other than 6 will be treated as poorly graded. So this is the basic concept of this problem. I hope you are clear with this problem. So let us move on to the next question, students. So students, just go through this question for a minute. Okay. Students, just go through that question for a minute. Okay, very good, students. Let me tell you here. Sir, see, read the question very carefully, sir. Everyone have to read the question very carefully. Okay, sir, see. The question here is the following data were recorded in a constant head permeability test. Internal dia of the permeameter is 7.5 centimeter. Head lost is over length is 18 centimeter. Is 24.7. Quantity of water collected is 60 second. In 60 second is 626 ml. Porosity of the soil is 44 percentile. Calculate the coefficient of permeability, discharge velocity and seepage. Sir, this is also a gate question. Means this kind of question was asked in a different form values. So let me tell you first of all, what do you mean by permeability? Sir, see students, what do you mean by permeability? Sir, if you have a tank, suppose, see what do you mean by permeability is, suppose if I consider this as a tank. Okay, in a tank we have valve here. See students, when you open the valve, water will flow. When you close the valve, water will not flow. So here this is the meaning of the valve, right? So what is actually permeability? It is the property of the soil which allows the passage of flow through it. Sir, the ability for the water to flow in the soil is nothing but permeability. My dear students, we have an important law. What is that? Is Darcy's law. We have an important law in permeability. What does this Darcy's law says is, Darcy's law states that velocity is proportional to hydraulic gradient. What is Darcy's law states, students? Darcy's law states that velocity is proportional to the hydraulic gradient. So what do you mean by hydraulic gradient? Suppose if a water is flowing from here to here, okay, with the different heads. Here if you see the head is H1 and here if the water head is H2. And the length here is, the length of flow is L. So what do you mean by hydraulic gradient is? Hydraulic gradient is defined as the delta H by L. What is delta H here? Anyone, my dear students? Delta H is nothing but loss of head, or you can write H1 minus H2, and length is the length of the travel. So here when x is proportional to y, if you have, you will write x is equal to some constant into y, right? So similarly, y is equal to written as I into k. So what is k? K is nothing but the coefficient of permeability. What is k, sir? K is nothing but, what is k? K is nothing but the coefficient of permeability. Agree? So see students, what do you mean by Darcy's law is, Darcy's law states that velocity is proportional to hydraulic gradient. And here what do you mean by hydraulic gradient? It is defined as the loss of head per unit length. I is equal to delta H by L and V is equal to IK, where K defines the coefficient of permeability. And according to the continuity equation, Q is equal to area into velocity. Finally, you can write Q is equal to AIK. And remember students, the discharge formula can also be written as, if you see the units meter cube per second, that indicates, or you know the basic discharge formula, it is defined as the ratio of volume upon time. So see students, with this concept we can apply the, means with the concept of this we can use the, we can solve the problem. So let me go into the problem. So here what is the internal dia of the permeameter is 7.5 centimeters, okay. And here what is the length and all, we will do this, sir. First I will calculate hydraulic gradient. What is the first one I will calculate? I is equal to hydraulic gradient, that is delta H by L. So it was clearly given, what is the loss of head in the problem? It was clearly given as loss of head is 24.7 centimeter divided by 18. So if you solve, what is length? 18 centimeter and remember hydraulic gradient does not have any units. Students, so I is equal to what, sir? I is equal to 1.37. Are you following, my dear students? Are you following or not? Yes. See students, actually at IMS Gate Academy, we offer online gate coaching as well as the offline gate coaching. And we offer the offline gate coaching at Vijayawada and also at Bangalore in Jayanagar. And remember students, whenever you are attending some coaching, it requires some beautiful content and also the material. So as part of the material, we have the exercise book, we have multiple subject tests, we have the chapter test. In addition to that, very good Varsha, in addition to this chapter test and exercise test, I feel two important things which are mainly helpful for the student success is my plan one-to-one mentorship session, and the second is the doubt solving portal. Whatever you post the doubt in the doubt solving portal, that doubt will be answered within 24 hours of time. So these are the two things which we could able to success. Now let me tell, what is hydraulic gradient, sir? Very good, Sai. The hydraulic gradient is nothing but 1.37. Agree, sir? After finding this, first, what is the discharge, sir? Discharge volume is given as 626 ml. What is the volume, sir? 626 ml. Okay. And remember again, my dear students, 1 meter cube is equal to, 1 meter cube is equal to, sorry, not meter cube, you can write 1 liter is equal to, 1 liter is equal to 1000 milliliter, or you can write 1000 centimeter cube. So here, if they give you the, why I am telling these units is, if they give you in ml or centimeter cube, both are same based on these conversions. So here discharge Q is equal to volume upon time. What is the volume they have given, my dear students? Volume they have given as 626 ml divided by 60 minutes, you will get 10.43, 60, 600, 42, 24. So 10.43 centimeter cube per second. So what is the value you got, my dear students? Here the discharge value you got is 10.43 centimeter per cube per second. Now see students, first what they have asked in the question, we'll see. First they asked you what is velocity. Okay, velocity can be written as I into K. Okay, velocity can be written as I into K. Let me tell you. So here what they have given, sir, the following data when a constant at permeability test. The internal dia of permeameter is how much, sir? 7.5 centimeters. Okay. Now see students. You know what is Q, amma? Q can be written as area into velocity. So what is area? Discharge, sir? 10.43 centimeter cube per second is equal to area. Area of the dia of the permeameter is how much, sir? Dia of the permeameter is 7.5 centimeters. So pi by 4 into 7.5 whole square into V. Yes or no? So what is the value of V, sir? Anyone, can you tell me? What is the value of velocity? Anyone, my dear students? What is the value of velocity you got? 10.43 divided by pi by 4 into 7.5 square. What is the value you got, my dear students? Anyone? What is the value you got, sir? If you solve this, velocity will be taken as how much? 0.236 centimeter per second. Yes or no? Everyone got this value, sir? Have you got this value? Very good. So velocity is taken as 0.236. Now velocity is equal to 0.236. What is the hydraulic gradient we have, sir? 1.37 into coefficient of permeability. So coefficient of permeability will be equal to 0.172 centimeter per second. So what is the coefficient of permeability? It will be equal to 0.172. The last one, this is the first one, velocity. This is the second one we have. The last one is seepage velocity. Seepage velocity can be written as velocity upon porosity. This is another important problem. Sorry, another important formula. Please write down, students. Seepage velocity means it is the velocity of the water which is flowing in the soil voids or in the voids of the soil particles. So this will be equal to, porosity is given as how much, sir? 40%, 44 percentile. So 0.172 divided by 44. You will get seepage velocity is equal to 0.536. Sorry, velocity is not 0.172. Seepage velocity is equal to velocity upon porosity, sir. What is the velocity we got? 0.236. Very good. Very good, Satanshu. It is 0.236 divided by porosity is how much? 0.44. So if you solve this, this value will be equal to this value will be equal to 0.536 centimeter per second. So here see, students, the first step you can write here. This is the first step where we have calculated the velocity. The second step we have calculated the permeability coefficient, and this is the third step. I hope you are clear with this problem. So what are the key takeaways in this problem is, remember students, Darcy's law states that velocity is proportional to hydraulic gradient. And remember students, hydraulic gradient is defined as the ratio of loss of head per unit length. And V is equal to IK, and discharge is defined as the ratio of volume upon time. and Q is equal to AV is the continuity equation, and we know seepage velocity is equal to velocity upon porosity. And remember students, after we are getting into the most interesting concept one by one. Once we are done with this, we will go into the effective stress, and then we will move on to the consolidation, and all those are very, very important. Okay. Now see, let me go to the second question. Sir, see, there are 3 soil samples each of 150 mm 150 mm long and 100 mm diameter are placed in a series in a constant flow head setup. The values of the coefficient of permeabilities are 0.01, 0.003 and 0.03 centimeter per second. Now see students, what is the concept required for this? Remember, see students, in a horizontal permeability, whenever you are finding horizontal equivalent permeability, see student, let me tell you, when I talk about these conditions are very, very important now. In a horizontal equivalent permeability, when I talk about horizontal equivalent permeability, when I talk about the horizontal equivalent permeability, here what I would like to tell you is discharge will be summation. These points are very, very important. In a horizontal permeability, discharge will be summations and head loss will be constant. Please understand this, sir. Head loss will be constant. Okay. In my other sessions, I have told you these derivations and all. In the YouTube only, you can see that if you want the derivations and all. In discharge will be summation and head loss will be constant. And remember, horizontal permeability also you can say that it is a parallel flow, because usually in parallel flow only we find the discharge is summation. Similarly, see students, are you following everyone? Okay, very good. Now next one we have is the vertical permeability. Next one what we have, sir? Vertical permeability. When I talk about the vertical permeability here, students, what do you mean by vertical permeability here? So this is known as series flow, you can write. In vertical permeability, you come across series flow. Here, important thing, discharge will be constant, discharge will be equal, and head loss will be equal to summation. Okay, so these things will help you. Sir, I'll tell you anyhow the problems, but the important concept is in a horizontal flow or in a parallel flow, remember the discharge is summation and the head loss is constant. In the vertical flow or in a series flow, discharge is constant and head loss is summation. And see students here, horizontal permeability KH is equal to sigma I is equal to 1 to n Zi Ki upon sigma Zi. And vertical permeability, similarly see students, vertical permeability can be taken as sigma I is equal to 1 to n Zi, sigma I is equal to 1 to n, sigma I is equal to 1 to n Zi upon Ki. So this is called as vertical permeability. So see students, this is the vertical permeability formula and this is the horizontal permeability formula. And remember here, see students, equivalent permeability is given by the formula square root of horizontal permeability into vertical permeability. Equivalent permeability is defined as the product of the horizontal permeability into vertical permeability. And remember the another important thing, and remember horizontal permeability, it is a mathematical proof. For now just remember this, horizontal permeability is always greater than the vertical permeability. So with these concepts, the problems on permeability in a flow setup, whether it is a parallel or a series or a constant head flow setup, like in a horizontal flow or in a series flow or a parallel flow, all these things will be done. Okay. Now see students, let us solve that problem. Sir, see, here he told that discharge is constant. He told in the problem, if you see the question, let me see. Sir, see, if you see the question here, he has used the word series. Yeah. See students, they have used the word series. Whenever they have used the word series, you should be aware that discharge is constant. So the first point what I would like to tell you is discharge Q1 is equal to Q2 is equal to Q3. Okay. Now see students, what is the discharge? You can write A1, I1, K1, because you know how you got A1, I1, K1, sir. You know V is equal to IK. See students, here you know V is equal to IK. And according to the continuity equation, Q is equal to what, sir? According to the continuation equation, Q is equal to what, students? Q is equal to area into velocity. So here what is area into velocity? You can write it as A into I into K. So Q can be written as AIK. Q can be written as what, sir? AIK. Am I clear, my dear students? Very good. So when I write here, A1 I1 is equal to A2 I2 is equal to A3 I3. Now see students, they have told that in all the three cases, diameter is given in the problem, each having 150 mm and 100 mm diameter. So if you see the problem, see students, in all the three setups, the diameters is same. So when the diameters are same, you can simply cancel area, area. After that, what we can write? I1 K1 is equal to I2 K2 is equal to I3 K3. And again, see students, what is hydraulic gradient? Hydraulic gradient is defined as the students. Hydraulic gradient is defined as the ratio of loss of head per unit length. So here you can write it as H1 by L1 into K1 or is equal to H2 by L2 into K2 is equal to H3 by L3 into K3. Okay, now see students, let me tell you the fact. In all the three setups, the lengths are same. So you can write here H1. So you can write here H1 K1 is equal to H2 K2 is equal to H3 K3. These can be written as some constant X I am taking. So we have derived one relation, right? So students, you can understand here clearly the ratios, like we have come up with one set, means one kind of equation. H1 K1 is equal to H2 K2 is equal to H3 K3. Now see students, let us understand the diagram. Sir, what is the total head loss here? What is the total head loss? The total head loss is 560 mm. Okay. The head loss for this one is one odd, sir. The head loss for this one is H1 and the head loss for this one is H2. This portion is H2, this one is H1 and this portion is H, which is equal to H3. Yes or no? So our intention is to find out H3 and it is a, are you following everyone? Very good. It is a series setup. It is a flow is a series setup. So see students here, when I talk about the series flow, here what I would like to tell you, total head loss can be written as H1 plus H2 plus H3. Okay. So here what is total head loss? It is 560 mm is equal to, what is H1, sir? X by K1. What is H2? X by K2. Please see the previous equation. H1 K1 is equal to X. So H1 is equal to X by K1. H2 K2 is equal to X. So H2 is equal to X by K2. H3 K3 is equal to X. So H3 is equal to X by K3. So we have solved X by K2 plus X by K3. And see students, they have given what are the values of K1, K2, K3. Again see, K1 is 0.003 and 0.03. So these are the values of K. So here K is how much, sir? K1 is X by 0.01 plus X by 0.003 plus X by K3 is 0.03. Okay, so these are the values, students. Okay, now you can simply say 1 into 10 power minus 2, so this is 100x, 3 into 10 power minus 3, so you can write 333.33x, and this is 3 into 10 power minus 2, 100 by 3, you can write it as 33.3x is equal to how much, sir? Is equal to 560 mm. So on solving this, you will get x is equal to 560 divided by how much, sir? 100, 433.33, 466.66. So on solving 466.66, you will get a x value how much, sir? 1.2. So x, you got a value of how much, sir? 1.2. Now how do you calculate the value of h is? H is nothing but h3. H is nothing but what, sir? h3. So x by k3. So you can write 1.2 divided by 0.03 will be equal to 40 mm. So the answer in that question will be equal to 40 mm. So let me tell you the key takeaways from this problem. So whenever they have given you the horizontal flow or a series flow, in a horizontal flow discharge will be summation, in a series flow discharge will be same. In a horizontal flow head loss will be same, and in a series flow head loss will be summation. Using those two relations we have derived this problem. Okay, we have solved this problem, sorry. Now this is another important question. Sir, see, we will see this question, but he is asking the word immediately after preloading and all. Okay, let me tell you, we will go into one simple concept. What do you mean by effective stress? Sir, what do you mean by effective stress? Sir, the word effective will come into picture when you are trying to utilize, means if you are having any engineering application, you are effectively utilizing that, that's how they might come effective stress. But let me tell you, initially when we talk about shear strength, initially Coulomb's has thought that shear strength is a function of total stress. But later see students, shear strength is a function of effective stress. Later Moore and Coulomb has spoken that shear strength is a function of effective stress. The reason is simple, sir. Why? Because effective stress is defined as the intergranular pressure between the soil particles. What, sir? What is effective stress is? It is the intergranular pressure. Effective stress is nothing but the intergranular pressure between the, it is the intergranular pressure between the soil particles. The intergranular pressure between the soil particles is known as what, sir? Effective stress. And the next point I would like to tell you, every time remember the engineering properties, means shear strength, compressibility, all those things, permeability, engineering properties depends upon the effective stress. Okay, and remember students, whenever we have total stress, remember total stress is taken as effective stress plus pore water pressure. What is total stress? What is sigma here, my dear students? Sigma is nothing but the total stress. What is sigma? Sigma is nothing but the total stress. Sigma dash is the effective stress. Sigma dash is the effective stress. And mu is the, U is the pore water pressure. What is mu? U is the pore water pressure. Okay. U is the pore water pressure. Okay. Now see students, we have different cases, sir. Suppose if there is a surcharge loading, if the loading is a surcharge, okay, we have the effective stress distribution which is linear. You can say stress is uniform, or you can say same, or whatever. Okay. In case of surcharge, this is the formula for what, sir? In case of surcharge case, sir, see, this is the vertical stress will be equal to Q. Are you following, students? Sir, see, next thing, if we consider a soil strata of depth Z, if we consider a soil strata of depth Z and it is having a unit weight gamma, so what will be the total stress, sir? Gamma into Z. Okay, this will be your vertical stress, total stress. Okay, now I would like to tell you one important thing, Amma. Students, am I audible, sir? Is this clear for everyone? Is this clear, sir? Can you please respond? Okay, so see here, vertical stress will be equal to the effective stress. Are you following, students? Vertical stress will be equal to effective stress when no water table is present. When no water table is present, total stress, or you can say simply, sir, students, you can say when no water table is present, total stress will be equal to effective stress. But if you consider a soil strata and it has a water table, then see, students, the effective stress will be taken as gamma dash into Z. What is gamma dash? Submerged unit weight. See, in case of water table, see, students, I might be fast in this concept, because in concepts you should be aware of the concept, and in these videos my intention is to solve the problems. So effective stress will be taken as what, sir? Gamma dash into Z. Now see, students, if soil is having different unit weights, suppose if the unit weights are different, here it is having a unit weight Z1 and here it is having a unit weight Z2. Then see, students, the diagrams will, here you can understand that slope changes. If you see the stress distribution diagram, slope changes. See, students, these things are very important. Just go through this for a minute, student. Just go through it for a minute. Tired. So let us see this question. Students, you might be excited. You should be excited because one very important thing, let me tell you, students. See, whatever the hard work you have done in the last 6 months, it is the time to accelerate yourself. It is the time to accelerate yourself in every concepts. Try to revise, go through the concepts, go to the formula sheet. If you follow these 3 mantra, like writing the formula sheet, third one short notes of every topics, and the third one is solving previous year gate questions and taking the key points from that. If you solve these 3 key points, means if you follow these 3 key points, definitely success is in your way. So I really appreciate Sai, Varsha and Shwetanshu. They have been trying to reply me, and Ranjit also. If you have any questions, any queries, just visit our Telegram channel. You can post your doubts and you can interact with the IMS Gate faculties. Now let us see this question, students. The question here is, the soil profile is set up to a depth of 10 meter and it is having a surcharge. The water table is at a depth of 3 meter below the ground level. The unit weight of the respective layers, everything is given. So immediately after preloading, sir, the word after preloading is very, very important. He has used the word after preloading. What is the immediately effective stress after preloading at P and Q? After preloading means there is no point in considering the surcharge. You should not consider the surcharge over there. So my dear students, the value at P will be equal to how much, sir? The value of effective stress. In this zone, if you see this zone, there is no water table. Whenever there is no water table, my dear students, you should just multiply gamma into Z, and here the unit weight is 18 and the depth of the soil strata is 3. So the effective stress here is equal to 54 kilonewton per meter square. What will be the effective stress at P? The effective stress at P is 54. See, students, it has a statement there. I told you, after preloading he has told. That is the reason we should not consider surcharge. If you consider the surcharge, again the problem will be wrong, because 54 plus 70 and that answer will be also there. So students, reading the question is a very important point. So let me go into the second point. What is the stress at Q? The effective stress at Q means, see students, whenever a water table is present, just replace the unit weight with submerged unit weight. So you can write here 18 into 3 plus whatever where the water table is present, you can write it as gamma dash into Z. So here you can write it as 54 plus, what is the value of gamma dash? Gamma dash is nothing but, I'll assume gamma W as 10 also, you can assume roughly 21 minus 10 into Z is how much, sir? 4 meter. So here we have gamma 21, I am assuming gamma W as 10 for easy calculation. So it will be equal to 98 kilonewton per meter cube. Yes or no? So what is the initial weight? Initial is 18 into 3 and next one we have is 21 minus 10. Okay, it will be equal to 11 into 4, 44, 98. So the option 1 will be the correct answer. Am I correct or wrong, sir? So the option 1 will be the approximate answer, sir. Clear? Any doubts in this? Any doubts in that, sir? Sir, I think they have given in the diagram as 21, but to get, I think they have given in the question 20. If it is 10, actually it is given in the question as 20, amma. A small correction, it is not unit weight is 21. So if you do 20 minus 10, you will get around 94. Okay. In the question, they have given as 20 kilonewton per meter cube. That is a simple calculation, sir. If they have given as 21, you will get 98. If they have given you 20, you get 94. So it will be roughly around the first option. That is 54 and 95. Okay. Sir, see, what is the ratios of coefficient of permeabilities? Sir, see, this is a simple question, amma. You have to find out KH. What is KH, sir? K1 Z1 plus K2 Z2, because there are two layers only, divided by Z1 plus Z2. Okay. So you have to find out the horizontal permeabilities. You have to see what is KH1. KH1 is how much, sir? 4.4 into 10 power minus 3 into Z1 is how much, sir? 20. And plus K2, horizontal permeability is 6 into 10 power minus 1. 6 into 10 power minus 1 into Z2 is 20 divided by 20 plus 20. So what is the horizontal permeability you got? Sir, here there is two layers, so I have taken this. What is the horizontal permeability you got, amma? What is the horizontal permeability you got, students? Anyone, can you please respond? You will get a value of 0.3447. What is the value? Meter per second. This is the horizontal permeability. Agree or not, sir? Okay. Now see, students, let me go to the vertical permeability. Sir, what is vertical permeability? Vertical permeability is given as Z1 plus Z2 divided by Z1 K1 plus Z2 K2. Here we have Z1 is how much, sir? 20 plus 20 divided by Z1 is 20 divided by KV1, because they have given vertical is different. 4 into 10 power minus 3. 4 into 10 power minus 3. K2 is how much, sir? 20 divided by 5.5 into 10 power minus 1. Yes or no? Okay. After finding this, what is the value of KB you got, sir? What is the value of KB? Anyone, my dear students, quickly respond in the chat box. So, if you see here, the KB value, if you see, students, you will get a value of 9.24 into 10 power minus 3. Just check it. You will get a value of 9.24 into 10 power minus 3. But what he has asked in the problem, calculate the ratio of KH by KV. So, what is KH, sir? Horizontal equivalent permeability is 0.3447 divided by 9.24 into 10 power minus 3. Okay. So, if you solve this, what is the value you will get, my dear students? You will get a value of 37.29. You will get a value of 37.2. So, it's a simple problem which we have already discussed on this. Now, let me go into the next concept. Sir, this is an important thing. Sir, the question, please remember, this is a question from stress distribution. Sir, see, a rectangular area 2 into 4 meter carries a UDL of 8 ton per meter square on the ground surface. Find the vertical pressure at 5 meter below the center and the corner of the load using the Bosnick's equation. Now see, let me tell you what is Bosnick's equation, sir. When I tell you about Bosnick's equation, whatever the load you are assuming, that you should assume as a point load. So see students, according to the Bosnick's equation, very good students, very good. According to the Bosnick's equation, if you have a point load of Q, and if there is a load at a distance R, the stress at a depth Z, sir, you can say, 1 second. This is a radial distance. Here the stress at a depth sigma Z is given by the formula Q by Z square into 3 by 2 pi into 1 upon 1 plus R by Z whole square whole power 5 by 2. Okay, this is the formula for Bosnick's equation. See students, when they ask you what is the vertical stress at a depth Z due to circular loading, if they ask you for circular loading, it is given by the formula Q into 1 minus cos cube theta. Okay. What is theta, you can ask me, sir. Here if I take circular loading in this way, okay, if I take this as theta, this will be the radius A, and if I take this as Z, okay, now cos theta can be written as what, sir? Z upon root over A square plus Z square. This is for circular loading. If they ask you for line loading or strip loading, 2Q by pi Z into 1 upon 1 plus x by Z whole square. This is Z, sir, whole square. So these are the formulas for stress distribution for different cases. Now see students, let us solve this problem. There is a rectangular footing, okay, which is of 2 meter here and which is of 4 meter. It has a load of 8, it has a load of what, sir? 8 ton per meter square. Just now I told you what, sir? Just now I told you students, whatever you are solving the problem in Bosnick's equation, it should be a point load, right? So total load can be written as what, sir? 8 into area, 8 into 2 into 4. If you see, this is the stress into area. If I do, you will get load is equal to how much, sir? 64 tons. What is the load you will get here, students? You will get load is equal to how much, sir? 64 tons. Am I clear or not, my dear students? Is this clear or not? Okay. Now see, student. Here what is sigma Z at a depth of 5 meter? Sir, see. One is asking at sigma Z at 5 meter center. Center means here at this point. So here at center R will be equal to 0. Okay, we know the formula is what, sir? Q by Z square into 3 by 2 pi. Just now I told you for Bosnick's equation. 3 by 2 pi into 1 upon 1 plus R by Z whole square whole power 5 by 2. Okay. So see students, here what is Q, sir? 64. 64 divided by depth is how much? 5 square into 3 by 2 pi. Here I told you R is equal to 0. So this will be equal to this entire 10 will become 1. So 64 by 5 square into 3 by 2 pi. What is the value, sir? Anyone, my dear students, what is the value? Sir, what is the value? You will get a value. How much is the value, sir? You will get a value of 1.22 ton per meter square. What is the value, sir? 1.22 ton per meter square. Now, another important thing they have asked you here is, at the corner, what is the values at the corners he is asking. What are the values at the corner means you have to find out R. The value of R at corner is how much, sir? This will be equal to 2 and this will be equal to 1. Okay, so it is equal to 2 square plus 1 square. It will be equal to root 5. Okay, so the vertical stress at center will be equal to 1.22 ton per meter square. Now what is sigma z, students? Sigma z is equal to q by z square. This is at where, sir? At corner. So q by z square into 3 by 2 pi into 1 upon 1 plus r by z whole square whole power 5 by 2. Okay. Now see, students, when I solve this, you will get already 64 by depth is 5 square into 3 by 2 pi. Are you following, my dear students? Is this clear? Varsha, Sai, Swetanshu, Rajat and all. Into radius, what is the radius, sir? Here we have, sorry, not radius, radial distance. Root 5 upon depth is how much, sir? 5 whole square whole power 5 by 2. So if you solve this, students, if you solve this, what will be the answer, sir? You will see, students, we got already, this is how much, sir? 1.22 ton per meter square. Because in the first case we have calculated into 1 upon, if you see this is root 5 by 5 whole square means it will be root 5, 1.2 whole power 5 by 2. If you solve this, you will get a value of 0.77 ton per meter square. Is this clear? So remember, students, whenever Bosnick's theory comes into picture, Bosnick's theory is best suitable for shallow foundation. If you talk about the point load, where the load is point load, sigma z is given by the formula q by z square into 3 by 2 pi into 1 upon 1 plus r by z whole square whole power 5 by 2. We have different formulas for line load, we have different formulas for circular loading, and we have another theory also called Westergaard's theory. That theory is suitable for stratified soil, students. Now, another interesting question, sir. Just read the question. I will give you 2 minutes of time. Just read the question, students. Students, just read the question. I will give you 2 minutes of time. Sir, see, here we have the interesting problem, Amma. What is the interesting problem we have is the vertical stress at some depth below the corner of a rectangular footing 1 into 1.5 meter due to a certain loading intensity is 100 kilonewton meter square. What will be the vertical stress in kilonewton meter square below the center 2 into 3 meter for a rectangular footing at same depth and same load intensity? So here see students. Sir, see, this is a beautiful question, Amma. Actually, they have given, there is a footing which is of depth, sorry, which is of width 2 meter, you can say, and this is 3 meter or 3 meter or 2 meter, anything. Okay, anything you can take, sir. Either this is 3 meter you can take or this one. So if you take here, so here this is how much, sir? What is this value? This value is equal to 1 meter and this value is equal to how much? This value is equal to 1.5 meter. This value is equal to 1.5 meter. So here see students, what is the value at the corner is, this is 100. They have given for this footing, which is 1 into 1.5 meter is 100. And due to this also at center it will be 100. And due to this also it will be 100. And due to this also 100. So see students, what is the vertical stress at center? Sir, why I am telling? Because for this footing, they have given the value at corner. Any corner it is 100. So at this corner it is 100. So due to this footing there is 100. Due to this footing it is 100. So if I take this one as sigma 1, sigma 2, sigma 3, sigma 4. So total effective stress at the same depth. Sir, if they have not given same depth and same load intensity, then it will be difficult. So sigma 5 meter is equal to sigma 1 plus sigma 2 plus sigma 3 plus sigma 4. So this will be equal to 100 plus 100 plus 100 plus 100. So this will be equal to 400 kilonewton per meter square. What is this value, sir? This value will be equal to 400 kilonewton per meter square. Am I clear for everyone? Now, see students, what I have observed in stress distribution, another important point I would like to tell you. The important point is, sir, see, in stress distribution, in a vertical plane, okay, if I take in a vertical plane, the maximum vertical stress distribution, it will be like this, sir, okay. And they can ask you at what angle, you can say, at an angle of 39 degrees 15 minutes. Okay, if they ask you where the vertical stress is or the stress at a depth z is maximum, you can write here beta value, when beta value or angle value is equal to 39 degrees 15 minutes. And remember, see students, when R by Z value is equal, they can twist in any way, sir. What is R? R by Z value is equal to 0.817. So here please understand, sir, what is R here? R is known as what, sir? R is the radial distance. What is R here? R is the radial distance. And Z is nothing but what, sir? Depth. Z is nothing but the depth of soil strata. Depth is nothing but the depth of the soil strata. R is nothing but the radial distance. So remember, this was a GATE 23 previous year question, sir. They have made another values and all, but remember, from the when the ratio of radial distance to the depth value is 0.817, we can easily solve the problem. Okay. So please read this question, students. I'll give you 2 minutes, sir. Good afternoon, sir. Good afternoon, Saurabh, sir. Good afternoon. Please read this question, everyone, my dear students. Now see students, let me tell you, thank you Saurav. Sir, let me tell you one important thing. We have a important thing that is called consolidation. We have an important concept called consolidation. See students, actually the main culprit or the main disadvantage of consolidation is a very, very dangerous sign is settlement. Due to consolidation and compaction, we are seeing a settlement. Sir, let me tell you one thing. The settlement can be fast or the settlement can take delay. So in consolidation we have three types. One is the initial consolidation, primary consolidation and secondary consolidation. But let me tell you the facts. See here in consolidation what happens is, if you see the Leaning Tower of Pisa which is done, the main reason is for consolidation. So in consolidation, let me go to the important formulas. The settlement here is given by the formula H into Cc upon 1 plus E naught into log of sigma final effective stress upon sigma initial effective stress. Remember my dear students, this is a very important formula in solving the problems. So here what is H? Remember H is always the thickness of the clay layer. What is H, sir? The H is always the thickness of clay layer, my dear students. What is the value? What do you mean by H? H is always the thickness of the clay layer. Now, what is Cc? Cc is the coefficient of compression index, which is given as 0.009 into liquid limit minus 10 percentile for undisturbed soil. This was the equation developed by the Terzaghi. And we have another case is from height of solids method, delta H by H is equal to delta E upon 1 plus E naught. Okay. Now see students, in this session I am just telling the formulas, how these formulas are utilized in the problems. So if you want to go through the actual concepts, we have a separate playlist on soil mechanics. You can visit that playlist where we have a detailed explanation. Now let me tell you, we have coefficient of volume compressibility is given by the formula delta V by V into delta sigma dash. So, and this formula can also be written as delta H by H into delta sigma dash. And remember here, see students, the volume, if you consider delta H, what is delta H, sir? Delta H is nothing but the settlement. Delta H is given by the formula mv into H into delta sigma dash. So this is the formula for settlement. Okay. Now see students, we have coefficient of compressibility. So they can ask you what are the units of volume compressibility. Sir, see here delta, the inverse of the stress units will be the units of mv. Similarly, the coefficient of compressibility is also given as delta E by delta sigma dash. And we have Cc, coefficient of compression index, is equal to E naught minus Ef into sigma final upon sigma initial. Okay. And remember two key points in this problem, students. Every time whenever you are calculating the settlement, you should take capital H, not the entire depth of the soil strata. You cannot take capital H is Sai, Swetanshu, Varsha and all. Are you following, sir? Remember, capital H cannot be taken the entire thickness of the soil strata. Capital H should be taken only the thickness of the clay layer. Okay. Apart from that, another important point I would like to tell you here is delta H can be delta H also can be calculated from using the formula mb into H into delta sigma dash. Okay. Now let me go through this problem, students. So let me tell you this problem. The question here is simple. A footing from a water tower carries a load of 900 tons and it is 3.6 square meter. It rests on a sand of 9 meter thickness over a clay layer of 3 meter depth. The foundation depth is 1.5 meter. The clay layer has a liquid limit of 54 percentile. Void ratio is 1.08. The unit weights of sand and clay are 1.89 and 1.7. Assume the load distribution to be 2 vertical or 1 horizontal. Remember students, let me tell you another important point. Sir, if they used the word approximate method, if they have not given 2 vertical or 1 horizontal, you can use the slope means how it has been distributed is 2 vertical to 1 horizontal, but definitely they will give you. So he's asking what is the ultimate settlement and is asking what is the maximum effective stress. So and the site is flooded. This is also important. The site is flooded is also very important thing, sir. Now let me go through this question, sir. So whenever these kind of problems are asked, students, first draw the diagram. So here we have the, so first I would like to draw the, foundation. Okay, foundation diagram. Okay, here they have told the foundation has a 9-meter depth of sand, and in that 1.5 meter is what, sir? Depth of the foundation. Okay, and here up to here you can say this entire thing is sand, and the unit weight of sand is how much, sir? The unit weight of sand is 1.89 ton per meter cube. Are you following, students? Next we have is what, my dear students? Next one we have is clay. And gamma of clay is how much, sir? 1.79 ton per meters cube. Okay. Now this is the size of the footing given in the problem, that is 3.6 meters, students. What is the size of the footing they have given? The size of the footing is given as 3.6 meter. Now we have a clay layer which is of depth how much, students? You have a clay layer which is of depth 3 meter. So remember what will be the capital H here? The thickness of the clay layer will be 3 meter. So here see, student, they have given the approximate how the stress is going to vary. Sorry, here if you see, here, one second. This is clay, Amma, if you want, this is clay, okay. So they have given it as 2:1, okay, or 2 vertical and 1 horizontal. Now let me do this. How do we calculate this? I'll assume this distance as x, and I will find out this value. Sir, what will be this value? Sir, please understand this carefully. The distance from here to here, this one is 1.5 meter for center of clay, 1.5 plus 9. So this will be total 10.5. Okay, the total distance here is how much, sir? 10.5 meter. Are you following, my dear students? So from that 10.5, remove 1.5. So this distance will be again, it will be equal to 9 meter. Yes or no, my dear students? So I'll assume this as x. So from interpolation, I can write 9 by x is equal to 2 by 1. And x will be equal to 4.5 meter. So x will be equal to how much, sir? 4.5 meter. Are you getting, my dear students? So this distance will be equal to 4.5. Sorry, whatever this distance, whatever we have, this distance will be equal to 4.5 meter. And whatever the distance what we are having here, this will be also 4.5. So the total distance, horizontal distance will be 3.6 plus 4.5 plus 4.5. That will be equal to how much, sir? Total will be equal to, so 9 plus 3.6, you can write it as 12.6. And now see, students, let me tell you the important point. How do you find out delta sigma? Delta sigma is nothing but Q upon whatever it is a square footing, sir. Sir, see, if you want to understand it is in a 3-dimensional way, there is a load here. Okay, and you are trying to find out this area, and there is a load acting which is acting. So the load is how much, sir? Here 12.6 square, because it is a square fitting. Load they have given as 900 tons, right? 900 divided by 12.6 whole square. What is this value, sir? Anyone, can you tell me what is that value quickly, sir? What is that value? Please tell me, students. Anyone, students, can you tell me what is that value? (900) divided by 12.6, sir. Have you got 5.61, sir? 144 something, 144 or something. 5.61 ton per meter square. Roughly you will get around right. Sai, have you got this value? Okay, now see, sir. Now we have to calculate what is the initial effective stress. Sir, are you getting me? What will be the initial effective stress? Sir, to calculate the initial effective stress, it is a flooded condition. That is very important, sir. If it is a flooded condition, now let me tell you. So how do you calculate is, there is a 9 meter depth, there is a 9 meter of sand, which is 1.89 ton per meter cube gamma value. This is sand, sir. And we have clay here. We have clay is how much, sir? Clay is equal to, gamma is equal to 1.79 ton per meter cube. Okay, now see students, here we have water table. So what will be the effective stress at here? Very good, Sai, very good. Okay, now what will be the effective stress here? Sir, if you get 5.66, just check it. Okay, 5.66. Now see students, sigma naught will be, as there is a water table, I told you whenever water table is there, my dear students, the effective stress will be calculated by taking gamma dash into picture. So gamma dash into Z1 clay of sand of Z1 plus gamma dash into clay of Z2. So here see students, let me tell you, gamma dash means it is always defined as the saturated unit weight minus unit weight of water. Am I clear, my dear students? So here sigma naught dash will be taken as 1.89 minus 1 into depth is 9 plus 1.79 minus 1 into 1.5. Okay, this will be the effective stress. What is the value of effective stress you got, students? Can anyone tell me? What is the value of effective stress you got? You will get 9.195 ton per meter square. What is the value, sir? You got 9.195 ton per meter square. So remember, students, I have calculated the initial effective stress and I have to calculate the final effective stress. Now what is the formula for settlement, students? The formula for settlement is H into Cc upon 1 plus E naught into log of sigma final upon sigma initial. Okay, sir. Sir, see, sigma final, please remember, students, sigma final can be written as sigma naught plus delta sigma dash. Now see, sigma naught dash is how much, sir? 9.195 plus delta sigma is how much, sir? You got 5.66. So if you solve this, 14.855 ton per meter square if you solve this. Okay, so you got final, you know also initial is how much, sir? 9.195. And what is H? Thickness of clay layer is how much, sir? 3 meter. And what is E naught given in the problem? 1.08. So we are left out with Cc. What is Cc called, my dear students? Students, are you following or not? So what is the value of Cc here? Cc is nothing but coefficient of compression index, which is expressed in terms of liquid limit 0.09 into liquid limit minus 10 percentile. This was the formula which was given by the Terzaghi for undisturbed soils. In the problem, they have given liquid limit is how much, sir? 54 percentile. So 0.009 into 54 minus 10. So here you will get a value of 0.396. So my dear students, I have calculated all the value. I have given you all the values. Thickness of clay layer is 3 meter. Final effective stress is 14.855 ton per meter square. Initial effective stress is 9.195. Now just plug in the values in the settlement and you will get H is equal to 3 meter, Cc is equal to 0.396 upon 1 plus 1.08 into log of sigma final. What is sigma final, sir? 14.855 divided by 9.195. On solving this, you will get a value of delta H is equal to 0.19119 meter, or you can write 119 mm. Is this clear? So my dear students, let me take the key points from this problem. What is consolidation means? It is the removal of water from the voids under a steady static long-term pressure. The next important point I would like to tell you is the important formulas are delta H is equal to H into Cc upon 1 plus E naught into, thank you Nag sir, thank you Nagi. Next one what I would like to tell you is delta H is nothing but settlement. What do you mean by settlement here is H into Cc by 1 plus E naught into log of sigma final upon sigma initial. Good afternoon Nag. So Nag, try to join tomorrow also. We have discussed the problems on today on the soil mechanics. I think you are in the law. So just go through this recorded video, you will get all the concepts. Okay. In the tomorrow's class, I'll be discussing more on foundation. So let me go through these formulas quickly, sir. Here you should take H is the thickness of the clay layer, C is the coefficient of compression index, which is a function of liquid limit. Okay. So by you should know what is effective stress. Effective stress is always calculated at the center of the clay layer. These things are very important. Now let me go to the other point, students. In consolidation, actually what is U? Sir, in consolidation, U is known as degree of consolidation. What is degree of consolidation means? It is defined as the settlement at a time by ultimate settlement into 100. What is degree of consolidation, sir? Degree of consolidation is defined as the ratio of settlement at a time upon ultimate settlement. Another important thing, remember there is a factor called time factor. Okay, time factor is given by the formula TV is equal to, time factor TV is given by the formula CVT upon D square. Okay, what is TV, sir? TV is equal to CVT upon D square, where CV indicates the coefficient of consolidation. What CV indicates? CV indicates the coefficient of consolidation. And remember here, students, if the coefficient of consolidation for single drainage, sir, see, this is very important. In coefficient of consolidation, we have coefficient of consolidation formula as CV is equal to K upon MV into gamma W, where MV is the volume compressibility, gamma W is the unit weight of water, and K is the coefficient of permeability. And see, students, in single drainage, the D value will be taken as thickness of clay layer. In double drainage, D value will be taken as H by 2. This is a very important. In single drainage, D will be equal to H, and in double drainage, it will be taken as H by 2. Now see, students, if the degree of consolidation is less than or equal to 60 percentile, then if the degree of consolidation is less than or equal to 60 percentile, then time factor will be taken as what, sir? Pi by 4 into mu percentile by 100 whole square. What is the formula, students? Here, when the degree of consolidation is less than or equal to 60 percentile, you can just remember as area of circle. That's how even I remember, because pi by 4 d square, I remember if the degree of consolidation is less than 60, I remember it. The other way is, if the degree of consolidation is more than 60 percentile, the formula, it will be somewhat tricky, but you have to remember. 1.781, in some gate questions, they have given you this formula also, sir. Okay, 1.781 minus 0.933 into log 10 into 100 minus U percentile. Okay, so what is the time factor for more than 60 percentile? Okay. Now see, students, they have asked you here, this is a very important question, sir. For the clay layer shown in the figure, MV is 5 into 10 power minus 4. 5 into 10 power minus 4 meter square per kilonewton. Okay, this is the value. And here what they have given is, here if you see, there is a surcharge loading, sir. Here they have given you a surcharge loading. Okay, and they are asking what is the settlement. They are asking what is the ultimate settlement. Just now I told you what is volume, coefficient of volume compressibility. MV is given as the formula delta H by H into delta sigma dash. I have told you just now, if you apply this, what is MV? Please write down delta H is the thickness of clay settlement, H is the thickness of clay layer, and delta sigma dash. So here if you see here, MV can be, MV into H into delta sigma dash will be your delta H. Okay. So see, students, MV is given as how much, sir? 5 into 10 power minus 4, which is given directly in the problem. But what is H? Thickness of the clay layer. Students, you have to be patient. As we are inching towards the GATE exam, you should show your enthusiasm. If you are studying 5 hours a day, then please push it to 7-8 hours. If you are practicing daily 25 to 30 questions, then please push it to 35 questions. So this is the crucial time. Whatever you have done the hard work from last 8 or 9 months, these 2 months are very crucial. So whenever you have a chance to revise the concept in a short and a stipulated time, you just visit our IMS Geotech platform. So for every branch we are coming live, for every concept on civil engineering, me and Pratik Mishra will be joining, and we have other faculties for other branches also. Definitely on this platform we are mainly focusing how the student time can be utilized in a more and efficient manner, and this can be achieved by solving the most critical problems and touching the concepts within a stipulated time. So here, how do we calculate mv into h into delta sigma is, h is 3 and delta sigma dash, how do you calculate delta sigma dash is nothing but a 2 meter depth is dumped. So you can directly apply 2 into 20 meter, because in the question they have given 2 meter depth is dumped with a, sir see, they have given the unit weight also. The unit weight is 20 kilonewton per meter cube. Okay, so I have taken 2 into 20. So if I take 2 into 20 means 6 into 20, 120, 120 into 5, 600. So 600 into 10 power minus 4 meter. Okay, 40. Please, this is 3 meter, right? So what is the value you got, Amma? What is the value you got, everyone? So 6 into 10 power minus 4. Sir, 5 into 10 power minus 4. Okay. 6 into 10 power minus 4 meter. Agree? Sorry, 1 second, sir. This is 5 into 10 power minus 4, no? Into 3. So 1 second. 5 into 3, 15, 20, 30, 30 into 20, 600. So 6 into 10 power minus 2 meter. Sorry. You will get 6 into 10 power minus 2 meter, or you can write it as 60 mm. So see students, what is the key takeaway from this problem is the settlement is given by the formula mv into h into delta sigma dash, where you will calculate delta h. One second, students. Now see students, see, if you talk about plastic equilibrium condition also, there is a condition called plastic equilibrium condition. This is also important. Okay, what do you mean by plastic equilibrium condition is, if the soil particles are near to the failure plane, then the soil is said to be in plastic equilibrium condition. If they are about to fail, we say that they are in plastic equilibrium condition. And here what I would like to tell you is sigma 1 is equal to sigma 3 into tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. Okay, this is the equation. And remember, see students, if they ask you how do we relate in shear strength, okay, if we consider a straight line equation, if a shear strength is on y-axis and effective stress on x-axis, if I consider this as phi angle, okay, and this is the cohesion, shear strength is given by the formula S is equal to C plus sigma dash tan phi. And remember students, when unconfined compressive strength is given, this is a very important, Amma. When you are solving any questions, the cohesion will be, sir, see, for gravel and sandy soils, the cohesion will be 0. For unconfined, if they have given you the unconfined compressive strength, the unconfined compressive strength is given, then cohesion will be equal to the half of the unconfined compressive strength. Now, let me tell you another thing also, sir. Now, see students, we have come across the another quantity of C pace formula also. Let me tell you another important formula. Quantity of C pace. Quantity of C pace is given by the formula Q is equal to KH into NF by NT. Okay, this is the formulas. So see students, in this session what we have done is we have covered the concepts of the soil mechanics. So in soil mechanics, first if you see properties of soil students, volume of voids by volume of solids is void ratio, volume of voids by total volume is porosity, gamma is equal to gamma W into G plus ESR upon 1 plus E, gamma D is equal to gamma W into G by 1 plus E, gamma sat is equal to gamma W into G plus E by 1 plus E. If you consider borrow pit and excavation problems, V2 by V1 is equal to 1 plus E2 by 1 plus E1. Air content is equal to volume of air by volume of voids, and degree of saturation is equal to volume of water by volume of voids. If you consider soil structure, clay mineralogy, kaolinite is the most stable clay mineral, illite is formed by potassium ions, and montmorillonite has the most unstable mineral. And specific surface area is inversely proportional to the particle size dia square. When I talk about index properties or soil classification, coefficient of uniformity is given by the formula D60 by D10. Coefficient of curvature is given by the formula D square 30 upon D60 into D10, where D30, D60, D10 indicates the sieve sizes, D10 is the effective size. We have liquid limit, plastic limit and shrinkage limit, and remember my dear students, the liquid limit is always greater than plastic limit, greater than shrinkage limit. Liquid limit is defined as the water content at which the soil has small shear resistance. Plastic limit means it is the minimum water content at which the soil can be rolled into 3 mm diameter without breaking. Shrinkage limit means it is the maximum water content, even though there is any further loss of moisture, there won't be any change in volume, or it is the minimum water content at which the soil is fully saturated. Next we have discussed is group index. Group index is also used to indicate the quality of the soil within the same group. And permeability, it is the property of the soil which allows the passage of flow through it. Velocity according to Darcy's law is given by the formula I into K, where I indicates the hydraulic gradient and K is the coefficient of permeability. Horizontal coefficient of permeability is given as sum of the discharges and head loss will be constant, or sigma I is equal to 1 to n Zi Ki upon sigma Zi. And vertical permeability is given by the formula sigma Zi by Ki, sigma Zi upon sigma Zi by Ki. And in vertical permeability, remember students, the discharge will be same and the head loss will be summation. And we have the constant head test Q is equal to AIK, and variable head test is equal to AL by AT into log E into H1 by H2. And the second important thing is seepage velocity is always velocity upon porosity. Quantity of seepage is KH into NF by ND, where NF indicates the number of flow channels, ND indicates the potential drops. So these are the basic things which we have discussed. Students, if you are really interested, if you want to these notes, if you feel these notes are helpful for you, in the link description also we have provided the Telegram group. This Telegram group, you will be updated with the recent YouTube sessions, like schedule of the, like what is the next class to be held in the civil or mechanical, and also you will be everything will be updated in the Telegram group. And apart from this, like why we have to choose IMS Gate Academy? I told you my dear students, let me tell you here one important thing. When I talk about the IMS Gate Academy, it has the most beautiful features. If you are thinking about online, then IMS Gate Academy is there. If you are thinking about offline in Bangalore, or if you are thinking about the offline gate coaching at Vijayawada, then IMS Gate Academy has these features. And remember, in IMS Gate Academy, we have one-to-one mentorships. Apart from one-to-one mentorship, we also have the doubt solving portal. We have the beautiful study materials, which was well published with all the practice questions of level 1, level 2, level 3. And we have done all the 30 years previous year gate questions. Then students, if you are looking for the gate preparation, and if you are a third year and final year, and it is the time, you have to start preparing, and you can just visit if you are looking for an offline, then visit Bangalore Jayanagar Center. You will have a demo access, and once you are satisfied with the lectures, definitely I hope you will be satisfied with our team and with our delivery. And we have the most experienced faculties who are from IIScs and IITs. And let me tell you, thank you. Tomorrow we are coming live in the evening 6 p.m. to 9 p.m. on the most awaited topic, foundation. Thank you, my dear students.